recently had a little bit of an aha moment on something that I was telling Mike about that I wanted to present to the crew. May not be aha to some of the gurus. Who are the gurus in the house? Who's some big JavaScript people? Come on, there's some of you in here. You're a little shy. Anyway, so async await was something that I kind of recently discovered how to properly leverage. I was really happy with it and wanted to bring that to the table. So really what I'm going to talk about are some asynchronous concepts, and I'm going to get to some asynchronous await. I'll talk about callbacks, I'll talk about promises, I'll talk about async await, and really show you some examples of some problems there. I'll struggle a little bit. I'm not nearly as prepared as I usually am. Not that means it's going to be a good presentation. I'm going to talk really quickly about call stack. This is going to be kind of pretty dry stuff, and you can ignore this for the later part of the conversation. The only reason I'm going to talk about it is because it becomes meaningful when you start thinking about a multi-threaded concept and the state of an application. But we'll throw this out here shortly, and we'll start talking about call stacks and promises. In JavaScript, it is a single-threaded application. Does anybody done any multi-threaded stuff? Yeah? Know what it means to be single-threaded? Single-threading basically means that your program can really only execute one step at a time. In other programs, you can actually spin off little processes, right? I can say I have a program doing this thing, and I need some other work to be done, and I can spin off some work, and I can go have a little thread doing that stuff. You can get multiple threads of execution. JavaScript is not like that. JavaScript is single-threaded. The code that you write really can only execute in one thread. But you'll know that there are things like set timeouts, HTTP requests, and things like that that do other work that are kind of long-running that do theoretically spin off another thread. So we're going to talk about the call stack a little bit, just so you understand what's happening. The call stack in JavaScript is LIFO, last in, first out. So imagine that you've got a set of steps. In fact, let's just cover it right here. Can everybody see the screen okay? See some of my functions? It's really dead simple stuff. I've got a function, CEO, CTO, VP of Engineering, Tech Lead, Developer, and they all have things that they want to say, right? And I kick the whole thing off with the CEO starting the process, right? So up in the beginning, none of this affects the call stack. We're just setting up functions, and the very first thing that hits the call stack is CEO, right? So that goes into your call stack. Sorry. Keyboard. Color. There we go. Can you see that? Yeah. Okay. So basically, the first thing that jumps onto the stack is the first line that gets executed, right? JavaScript comes down here, sees CEO. It adds that to the stack. So the first thing it does is it jumps into the CEO function. It adds that console log to the stack. Why am I not getting colors here? Oh, because it's copying from my thing here. Say again? Yeah? Yeah. All right, here. I know what I can do. What's that? Trusty notepad. All right, we'll just go from here. All right, you can still see that? So yeah, so the first thing that goes in, right, once we hit there, is it hits the call. Oh, God, night. Like I said, I'm not nearly as prepared as I usually am. All right. So it hits this call, console log, and it sticks that on top of the stack. But admittedly, that resolves immediately, right? It executes the console log, and it drops it from the stack. and it adds the next call in line to the stack, right? VP of engineering gets dumped on the stack. We get the next line inside VP of engineering. It goes in and immediately gets resolved, right? Tech lead gets put on top of the stack. Console log gets put on the stack, executes console log, gets dropped off the stack. Developer gets dropped onto the stack. Console log does as well, right? Console log clears, developer clears, tech lead clears, VP of engineering clears, CEO clears, your program is completed executing. Right, last in, first out stack, right? You kind of get that? Yeah. Any questions about a last in, first out? Okay. The only thing that's a little bit different about that is when we go into what's called, right, so to be clear, when you write code, all of your code executes in this stack. Nothing that you write will run outside of that last in, first out stack. It's just the way that it works. You can't put anything into a threaded state. With an exception, it's saying that you can call browser functions, right? If you make an HTTP request, that spins off a thread. If you call set timeout, that spins off a thread. If you call DOM event handlers, those spin off threads. So you have browser-specific executions and things like that that have their own context, and I'll show you how that works. Okay. All right, same concept here, right? I've got a program that kicks off. This one's going to start executing immediately, but I've got a function call that I've defined up at the top. Everyone see that? Yeah. Inside there is a set timeout call. I'll show you how that resolves here in a second. Anyway, the very first thing that gets executed is console log. So if we start running this through the call stack, right, the first thing that actually gets hit is this console log, and then it resolves immediately, right? Some long-running task gets hit, so we jump into that, and it fires set timeout. Set timeout is a special case, right? That is a browser-specific function. It's going to resolve immediately, and immediately go into this other thread of execution, right? Set timeout resolved here in our stack, so it's returned, but it's actually doing some work over here. Okay, so set timeout is now waiting 5,000 seconds, doing its work. Meanwhile, we're clearing, right? We console log, we clear, we hit done, we clear. Meanwhile, set timeout finishes, okay? It finishes doing its work, and it's got a set of executions or a set of statements in here that it's going to now try to bring back onto the stack, right? So it has finished that work up. It puts its stuff in the event loop, and the event loop basically is sitting there waiting for our call stack to clear, okay? That method, that set timeout thing finished up and said, hey, here's the next statement that the programmer wanted me to execute when I'm done. Stick this in the event loop, and now wait for the call stack to clear, and you can now inject that, right? So the call stack is cleared, that executes, it resolves, and then everything is cleared out, right? It's a conceptual thing. It probably won't hurt you if you don't really get it. It'll help you a little bit if you understand some of the concept. Okay, yeah. The only thing that you really have to know is that when you have things that are fired off into that thread kind of a state, they will not come back into your code and execute until the call stack is clear, right? So as long as you're doing work, and I can demonstrate that. So, we see this stuff okay? So if I go into the call stack piece, this is the same bit of code, right? You can see that I kicked off. Let's see if I can pull this up where you can see. right? So reload this. You can see I fired the console log. We fired this off. We called console log fired off. We hit done. And then 5 seconds later, after my application completed, right? So my application completed here theoretically, but I still had this thread kick off 5 seconds later to resolve. Okay? So basically that means the stack was empty at that time. What I wanted to demonstrate is there is theoretically a concept where you can hog the call stack, right? You can keep it from coming back. Do you guys understand the concept of a tight loop? A tight loop basically is a loop where it's an iteration over things that doesn't release the call stack. So if you look at this, well, at least it's not going to for 20,000 cycles, right? So if it's the same code, but I'm going to put this for loop in here, and it's not going to release anything for 20,000 cycles. I've changed the timeout on this to be 40 milliseconds, so pretty quick, if that makes sense. It's going to be pretty quick, but what you'll see is when you execute this, right, so it's cranking through these cycles, but it still didn't get that completed call until well after 40 milliseconds later, and still after my method completed. Does that make sense? All right. All right. So that's just a conceptual thing. I wanted you to understand that we have a call stack that we maintain. It's single threaded. There are things that go into another thread, and we're going to talk about how we handle the response back from those guys. But I need you to understand too the concept that when you fire these things off, they don't resolve if you have something looping hard, doing a lot of hard work at the time. It doesn't happen a whole lot really in our code, right? So in our browser code, most of the time we're waiting for click events, we're maybe running an animation, and we have cycles and things like that we're going over. We're not usually doing a whole lot of hard calculations there. It's really a whole lot of idle time. So the call stack is really empty most of the time, or it's kind of queuing one or two things and it's cycling out and it's going empty. So when you have these things thread off, they queue up right away, and it looks like you're getting this concurrent application, right? It feels like these things are all happening at the same time, but really it's just keeping that call stack empty and it's throwing things into the stack. Does that make sense? Yeah. Any questions there talking about some of the call stack stuff? Is that was that too much? Yeah? Yeah, go ahead, Levi.
Would browser functions like prompt, confirm, or alert also hold up the call stack?
Yeah, so those are blocking. Yeah.
Yep.
Yeah, anything like that's going to block. I don't have a list of all of them that fire out, but yes. In fact, you'll see that on an alert or a prompt. They'll stop all execution kind of thing because they're waiting for user input. So really, yeah, you can't fire anything off until the user provides the input and allows the program to continue executing. And literally, it has stopped every single execution at that point. Okay. Okay, so some of the things that we can do to be a little bit more multi-threaded, right? So we obviously have calls and we have things that we want to do that are longer running. We talk to databases, we talk to web APIs, we do some file I/O, right? And if our program were to stop and have all of those functions always execute to completion before we continue doing anything, our UI would become really unresponsive, right? So typically, once you have these things that fire off into the browser APIs, right, that's a separate thread that's doing their own thing. We can clear our call stack. We do that mostly by firing off and registering typically what's called a callback. You guys familiar with the callback concept? So what you do is you fire off this method and you say that you want to know when it comes back. So I'll start with this typical scenario, which is a callback, right? Can you see it?
It's there.
Yeah? I'm doing this in Node.js rather than in the browser, so I'm going to run it here on the command line down at the bottom here. So this would be something like your jQuery get, right, or your It's an XML HTTP request. So basically just registering a library up here. I've got a function called run. Think of it as a main. And it's got a callback that I'm registering here. So that's how I can tell my caller that I'm done. And at the very bottom, I'm kicking the whole thing off, right? So I've got one function called run. At the bottom, I'm kicking it off. And I'm basically passing into this callback this handler. So I'm saying run, and when you're done, call this function, just to let me know that you're done, okay? So we kick it off, this goes into the call stack, and basically it's immediately running this thing right here. This request fires off and goes into that browser API thread, and we register with it that we want to get this callback here, right? So make this web request, free up the program to do everything else that it's going to do, right? So we've cleared our call stack, we made the request, and we're basically saying, when you're done, let me know. Here's the method signature for you to execute, right? Go make this request, call back this function, let me know if there was an error, let me know if there was a response, right? If there was an error, I console log the error, and then I call back up the chain, right? So I'm going to say, hey, I got a response, there was an error, and I can tell my caller there was an error. If there wasn't an error, I can spit the response back out to the screen, and then I also just call back and say, hey, I'm done, kind of thing. Totally foreign to anybody, or pretty familiar to most people? Yeah? Come on, tell me, seriously. I know the JavaScript front-end guys, the callback concept will be there, right? We do it all the time. This pattern you see all over the place, kind of thing. Right? So fire it off. We hit the trusty quip vid, get Mike's quips, and you can see that at the very end of the process, we're done, right? So if we didn't do it with any of the callbacks, theoretically, right, we could make this request go off, it'd fire off, and our application would complete. We just never know, right? So really the callbacks are just saying, hey, do your asynchronous thing, let me know when you're done. I want to handle that stuff in a certain way. I'm going to move on to a promise-based execution of that next. So if you have questions about callback, let's stop there.
When you're running Node,
yeah,
how does it know to stop executing if you don't do something? Like, does it just track the call stack?
Yeah.
If there's still something in the call stack when you're Node?
Yep. In fact, I have a scenario to show you where it fails, where it falls. I'll demonstrate that when we get into Mongo, because yeah, you can actually leave the stack open to a point where the thread in your program feels like it's done. There's no code left, but there's still a resource tied up that's never going to release, and that will leave the program, keep it from stopping, kind of thing. Yep. So this is not a great example of where callbacks get ugly. Callbacks are ugly. You'll see it in a later demonstration. What happens with callbacks is you end up nesting them a lot of times, because you want to do this thing that's asynchronous, and then when that's done, do this thing that's asynchronous, and then when that's done, do this thing that's asynchronous, and you end up nesting all of your code pretty deeply, and it gets pretty hard to read and pretty hard to follow. A few years ago, they introduced this concept called a promise. It's still the same concept. It's still the ability to request something to go off and to tell me when you're done. The syntax is just a little bit different, right? So instead of registering a callback, we tell it, I'll just show you. The same library basically up here, request, except that it's a little bit different in that it returns a promise rather than a callback. We have a function that we're going to execute, and we're going to run, and here's the difference right here. We're returning a promise. When we return a promise, it's a guarantee that we're going to respond, okay? So what happens is what we know that when we call and we get a promise back, so we're going to call this thing, and immediately it gets a promise back, and when that thing is done, it will call this resolve, and that can be surfaced here with a then, right? So I'm going to say, hey, go run your thing. When you're done running, then do this. Does that make sense? Yep. So that's really what's happening here too, right? Oop. Right, so I'm saying run, I'm getting back a promise, it's doing this work, so it's saying, hey, make this request. This is returning a promise too, right? So inside my call, I'm making a request, and before you saw I had this kind of call, the callback piece in there, right? But instead I'm saying then, hey, when you're done making this request, then you give me the body back. I'm going to call back, I'm going to print that out to screen, and then I'm going to say, hey, I'm done, right? My run function is complete. You did your thing. The guy that called me wants to know. I'm resolved. Or if I get an error, I call this error, and I can reject. So this is me promising to respond. And I either said everything's okay, everything failed, right?
When you run without a thing, nothing happens. It's the same as declaring a promise.
No, because that's a little bit different. What you're talking about is subscribe. Are you familiar with RxJS? It should execute without the then. It just won't come back, right? Promise. Right, so it's going to go fire off and do that thing. It grabbed all the stuff, just never said it was done. Does that make sense? So yeah, theoretically, if you don't care what it does, you have a post, or you want to send an email or something like that, and you just want to fire that thing off and you really don't care if it was successful or not, you can leave the then off, right? You just say, hey, fire the thing off, and if you were good, great. If you were not, I wasn't going to do anything about it anyway, right? And that's the same difference, right? I don't have to handle the then, but if I do, he'll let me know, and I'll know the application is complete. Theoretically, right? So it hits that thing. It reached the end of the code long before it did anything. Did you guys notice that? Right. So the call stack was empty really early, but then it fired those other things off, put those things back on the stack, and then resolved. Talk about promises just a little bit. Great tool. In fact, they solve a lot of the kind of ugliness of callbacks, because you have this thing that you can do called chaining. So I just wanted to demonstrate that really quickly. I got a quick function up here called test, right? Just returns a promise, and it returns some text. So you don't always have to return a promise, but you can. But inside the then, there's a little bit of a special handler. So I'm calling this test, right? And then I get my data back. So at this point, data, right, is equal to text data. I can console log that out. But theoretically, at this point, I can return another promise, right? I can fire off another asynchronous thing. Or if I return like this and it's not a promise, it acts like it is, right? It does this little trick where it makes it act like it's kind of another promise, and I can chain that all the way down the path. At this point, it's the same data, right? So this is effectively the same thing as this. So if you do a return at the end, it's shorthand for doing this same thing right here, right? This may feel a little bit weird, but I'm calling test, and then when it responds, I'm doing this thing, and I'm returning another promise. So then when this method call finishes, then I do this. And when this one finishes, then I do this, right? So it's a way just to keep the text going in sequence. Ooh. I haven't actually run this one, it may not run. There you go, right? So you can see that it just kept passing that text data through to the thens, and then super done. But theoretically, this could have been another another asynchronous call, could have been whatever work. The only thing that's really nice about it is that it keeps you from doing this deep nesting. Okay? Alright, so here's the one that I really like. Going back to, right, so we talked about callbacks, we make a request. We did the same thing with a promise. Async await. Okay? So while I think that this is much improved over callbacks, it's still pretty heavy, still pretty verbose. And async await allows us to really trim that down. If you'll notice down here at the bottom, the call into the method is exactly the same as it was for the promise. Okay? They are the same. They are the same structure. That's because an async function, and that's the key word here, and that's the difference. You guys see the async function at the top there? That key word basically is telling the whole system this is a promise. And that was the aha moment that I had, right? So I thought async, this is so crazy. This is some really weird stuff, and I don't even understand that. I kind of get promises. I kind of like using those. Yeah, it's still a little verbose. I'd really like someday to get async await going. But it feels weird. I don't get it. It really is this simple. You put this thing in front of your function. It converts that to a promise when it's running. So you treat this function like it's returning a promise, like it is a promise, because it is. I will tell you this, and it may be hard to understand. This code that you're looking at here, the call stack, I will almost guarantee, is identical to this. They do exactly the same thing. The syntax is just a little bit different. We wrap it up into an async, and then that tells this, right? It made this call. It knows that that's a promise. It then responds back out. The trick is that once we are inside of an async call like this, we get a little bit of a syntax helper called await, right? So before, we were inside our promise, and we had to do a request.then. We now have this syntax piece that says await, right? So instead of request.then, I can just say, hey, let this body response just wait for this thing and put the response here, right? Theoretically, I could say request.then and do all that kind of stuff. The fact that I've got this async identifier up here, it just gives me access to this. Anything that was a promise before, I can put an await in front of. Anything that's an async function, I can put an await in front of. So instead of calling a .then, I can just wait the response and grab the data, right? What happens is at the very end, there's an implicit resolve, right? So if you exit your function, you notice back here we had a resolve and a reject, right? We're not doing that in async await. We're throwing an error, right? Or we're just letting it execute and finish. There's an implied resolve if you don't return anything in the very end. So in here, if this were the promise, it'd have a resolve right here. You don't have to type it in. You're an async function. It wires it up for you.
Is the throwing of the error implicit reject?
Yes. Yep. In fact, if you have a method outside of your async and you call this, you can catch that with a dot catch or whatever. And you should find it. It's precisely the same execution as really the other two.
So in order to have the catch in there, you should have the whole thing with a try catch.
Yeah, you don't theoretically, right? You don't have to. If you trust all of your stuff, if you trust all the code to execute and it's not going to fail, it could be that simple.
But if you had a catch on the run, it wouldn't do anything?
Yeah. So this actually will throw the error, and right now it's not being handled. It's going to bark at you in this case and say you're not handling an error.
So it implicitly creates that for you. That's
yeah. In fact, here's the error, right? So I changed it to this URL that doesn't exist. It got caught down here. In fact, you're seeing the JavaScript engine down here complaining, saying hey, there was an error thrown that you didn't handle, kind of thing. And in fact, it was a promise rejection. See what I'm getting at? I mean, it's saying it's a promise rejection that you didn't handle. It's the same thing. And that was the aha moment, right? I got promises and I was starting to kind of get them. And once I realized that wrap and async just promisified everything that was inside of it, and that I could then await. Once you get inside of this kind of a call stack, right? So once your call stack has async in there, and you're in that frame, you can await anything that would be a promise. Does that make sense? So what I like to do in my programs, make the first method an async method, right? Get into that thing as fast as you can, and then you can write await calls instead of thens, right? So I just kind of try to dump into an async method early, and then I know that all my calls will be awaits later rather than trying to use the ugly other syntax. I've started to get into the point where my libraries that I write, when I have like an export or I have something like that where I'm exporting methods, I make them all async methods, right? They're always a promise, everything puts out a promise. So anything calling me can do a dot then and get the response, but anything I want to chain down, I can use awaits for, right? I'll get to it here in a little bit. I've done a fair amount of Node.js stuff and Mongo stuff, and once you get to the point where you're processing a boatload of data, some of these things get super nasty using callbacks. I mean, brain bender ugly kind of thing. And I've started refactoring those things, and just like get a little bit giddy when I see how clean and how readable they are here, right? So in the async await, you've got this thing, which is really natural and easy to read, right? It's like, let this happen, do this, goodbye, right? In the callback, it's the, hey, jump in here, do this thing, okay, get in there, get back out, right? Or it's just, just this nice kind of flow down, right? Promises are better, they flow down, but they still just are a little bit more syntax. Make sense? I'll get into another scenario where we'll blow that out just a little bit, right? So blowing this out, so it's the same thing, right? I make a web request out, and I want to save that to a file. So that's an example where I have two asynchronous things that I want to do, right? I want to go out and I want to grab the quips, and then I want to write those things to a file in the file system. So it shows you here in callbacks where that has to nest. You can see that I've still got the initial run call here. I request it out. If I get an error, I dump, right? I get back out and say, hey, I got an error. I'm not interested in going any forward anywhere. Otherwise, I call write file. Write file also takes a callback. Oh, I should have been consistent in my syntax. I'm sorry, I was not. This syntax is the same as this. It's a different. I'm sorry. That's probably a little bit confusing. This is the callback, right? So up here where I've got this function call, that's the callback. Same thing here, right? So I'm saying make the request. If it's good, write the file out to here, pass the body into the right file, and then when you're done, let me know if there was an error. I call back and I let my original caller know if I had an error. If I didn't, I say everything was saved, and I call back and everything was good, right? So this just shows where callbacks start to get this kind of a nested kind of a concept, right? I make the request. When that's done and that's good, inside that request, I make another request, and inside there, I call back and I say that it's good, right? Right? File's been saved, everything's done. Questions? All right. I'll go over the same concept with the promise, right? Again, so the only thing that I've really added here, and this is where promises clean that up a little bit, right? So how callbacks start to nest a little bit more deeply. Promise, you start to see this more vertical flow, right? I make the request. When it's done, right? When it's done, I return write file. Write file is bringing back another promise, right? So my next then is, hey, when that write file is done, I can call back and resolve. And then I can catch both errors, right? So if this thing errored or this thing errored, this one place handles all those errors and basically sends back the rejection at that point and kind of moves on to the end. Does that make sense? It is more readable, right? In my mind, promises are good. They are more readable from that perspective, right? Make the request, do this with the body, write the file, do this when the file is done, right? I'm not going to execute that one. I think you guys understand that it runs. I can break it or do something like that. But this is where async await starts to really shine, right? So I added another call right here. You see what I'm getting at? That's all I did. I didn't change anything. I added one line right here and said, hey, write the file, wait for it to finish, and then just finish up the execution. Again, from a call stack perspective, this is identical to that. Cool. All right. Is any of that stuff kind of sinking in? Everybody's saying, oh, I kind of get async await? Because if there's one thing that I think you can walk away with that I hope is valuable, is that async await is pretty easy, and it's really, I think, in my opinion, the way to go, right? And the code is just so much more readable. So if you have any questions and you still don't feel like you get some async await stuff, let's talk about it, because I now find it pretty straightforward, and I will use it for just about everything.
So that await, it stops the call stack as well as what it finishes.
Yep. Yeah, if I didn't have that in front of it, it would go ahead and clear the call stack, and it would execute on, and I would never get this, theoretically, this done or whatever, right? It'll still write the file. I just won't know that it was successful or it failed, kind of thing. I won't be able to catch that error, per se, or even... basically, that's just saying wait for the response.
One of those functions is a return variable is still await.
Mm-hmm. Yeah, because the fact that it's not returning on the promise call, if you saw the promise call, it was a then nothing, right? So it calls the right file, and then it handles basically an empty response. So that's effectively the same difference with async await. Is basically it's saying there's nothing to assign it to, right? You can wait for it. Didn't actually return anything. It just did its thing and then said it was done. Does that make sense? Catch the error. Okay. I am going to dig this just a little bit deeper on a couple of things. So parallel execution. I don't know if I'm entirely losing anybody or if you guys are keeping up or not. It's awfully quiet. I'm awfully anxious about my preparedness here, so I'm happy to stop and talk or happy to do anything, but so far what we've done are serial executions, right? We've done a couple of things in a row. We did this and then we did that. But imagine this world in which not only do you want quip vids, but you also need to know some cat facts, right? And there's no reason that your program has to wait. You have to go out and make an API call and get all the quip vids, and you have to go out and get all the cat facts, but they don't have to happen one after another, right? Hey, I need both of them. I should be able to fire it off and say, hey, go get both of these things. Let me know when they're all done, right? So this is just really an optimization to some async await or some asynchronous JavaScript. It doesn't always have to be serial. You can parallelize tasks. You can say, here are some things that I want to fire off all at the same time. They aren't dependent on each other, right? Nothing changes in the run call. I'm cheating here with callbacks because I really don't know what the good pattern is with callbacks to do this. I've got this great library that I use called async. Okay? I'll talk about it in just a second. It's really easy to understand. But maybe there's a different pattern that people use for callbacks. I don't do this stuff anymore in callbacks. I use async await. You'll see why it's a lot cleaner. But basically what I can do is I can create an array of things to do, right? And I'm going to tell this, hey, push this function clicking that. I push this function into the array, and this function is a request out to get quip vids. In fact, you'll see it's the same request we had before. I'm getting the quip vids, right? If it's an error, I'm returning an error. If it's not, I'm returning the body of the quip, right? The quip vid list. Then I'm pushing another one into the array to get cat facts. It's exactly the same call, right? It's a little bit verbose. They're making HTTP requests, and then they respond back when they're done. So I've got an array. It's got two things in it that I want to execute. And then the async library has this nice parallel function, right? So I can say, hey, parallelize everything in this array. The array has functions in it. When it's done, here's my callback. Return back any errors. Return back any values. Right? So theoretically, both of these can error, and I'll get 2 errors in here. Both of these will return values. I'll get 2 values in here. Or if it had 10 things in it, right, it would have 10 values and 10 errors or whatever. So this is really just saying, hey, for everything that's in here, call them, get the callbacks. When all of the callbacks are done, here's my callback to handle it, and you can see really, right, hey, how many values did you get from each? So the fun thing there is that you can see that I kick off quip vids first, right? So you can see, hey, I requested quips first, then I requested cats. You can see the cat facts came back first. So Mike, in his quip vids database, it's a little bit slower than the cat facts database. So you can see the order in which they return doesn't really matter. I fired them both off at the exact same time. Cat facts didn't have to wait for quip vids to finish. In fact, finished first, right? Then quip vids was done, and you can see I've got 517 quips and 195 cat facts. Right on? You want to see that as a promise? All right. All right. Same concept on the kickoff. Promise has this concept called a promise.all. Right? It also takes an array. I don't know if you can see it right there, but here's the array marker. And I'm just cheating, right? Here's the array marker, and here's the array end marker. So I'm saying promise.all for everything in here. And here's one method. Request the quips, request the cat facts, log the response, right? So really I'm just dumping two functions into promise.all. And then again, when I'm done, I get the quips and I get the cat facts. Again, I wasn't consistent in some of my structure here. This is the same thing as that values array. It's just that I automatically also separate it back out into separate lists. Only difference too, I didn't console log when it fired it off. It's a little bit of a syntax structure difference right here, right? I'd have to write an extra function in order to fire off the console log before I made the request. It'd be a little bit dirtier to do that, so I just left it off to keep this just a little bit cleaner. But you can see, again, cats was done, quips was done, same response. Async await. All right, so here's the deal. Because async await, because async functions are also promises, I also get access to promise.all, right? I can pass these async functions into promise.all and await that promise.all to complete. In fact, so before on the promises, right, I did a then and I got this. In the async await, I'm just awaiting promises and I'm putting it here, right? It is still a little bit kind of verbose here. This is what I was talking about, having to write the extra function to wrap up this call before this one. But conceptually, right, I promise.all, I wait for all of those to complete, I get quips and cats back. Cat's done, quips done, 517. Because this is a little bit contrived, I cleaned this up a little bit because I wanted you to see what the code can actually look like without some of the extra stuff in here to make it visible in here. So on the callbacks, I just cleaned up some of the console logging. You can still see that it's 2 tasks being pushed into, and then a little bit of depth here, right? Promises is much cleaner though, right? So you can see I can make that 1 call and then it, and get back a promise resolve with the body, so you can actually get a little bit more cleanliness there. And then async await is just super clean, right? And that for me is just like, I mean, come on. That's so readable, right? It's just so much more readable. And then you get into this stuff where it's like, I kind of got lost, right? I can follow this. I can follow that all the way down the chain and kind of get where we are and what happened. Yeah.
So, Tom, the goal here is to make the JavaScript application more responsive by
Yep.
eliminating blocking calls.
Yeah.
Your examples are specifically calling URLs. Just, I'm assuming because those are probably some of the slowest calls around and are unpredictable at least.
They are.
There other typical situations where you might want to use async await that you've seen?
Yeah, really. So anytime, really anytime that you have, again, so you can't write any asynchronous or you can't write any threaded code yourself. So it's almost entirely when you're using services or you're using other things that you're going to get that effect. And honestly, I'll tell you the truth, Jason, what happens is that you kind of fall into the pattern naturally, because every API call that you're going to call that's asynchronous, you're going to have to write a .then for or something else anyway. You want to write a file, it's got a callback. You want to make a web request, it's got a callback. You want to, that one's not a good callback, but the DOM events have a callback, right? They all naturally have callbacks because that's the only way they can inject into your call stack. So honestly, you just fall into the pattern because all of the method calls that you would want to go to that way, it would kind of require that execution. Yes, there is a scenario where I have tight loops. So there is a way to open up your tight loops and allow them to spin off and wait. In fact, I'll show that in the next piece. Yeah, I'll show that in the next piece, because tight loops are the ones that are in my mind, are the tricky scenarios. I do have a big array of things that I do need to do something to those, that I may have blocking calls that I have to do to those, right? I want to manipulate the data, I want to calculate an MD5 hash, that'd be something that would be blocking, unless there was something implemented. But yeah, that'd be a blocking call. So if you had something like that, that could be basically a long set of blocked or held up call stack. Yeah. This one? Yeah, I probably could. Yeah, so not this one, but I probably could hit like the callback version, really. Really, so yeah, here, let's start with just the basic one and see if I can track it through. You hit your run. Right, so hit your run. And the first thing that does is fire off request, right? So request hits your stack. Come on. Alright, so hit your run. It hits request. It hits run. Gets request. We did this before, didn't we? Alright, so you hit your request, and your request is an API call. It's a browser API call. So it immediately is going to come off the stack and go over into the browser API work, right? So at that point, I don't have anything else on the stack, right? That in fact, that's exactly the point where before you saw that I had this console log super done, right? Theoretically, if I had that there, that would execute right now. So I hit run, it stuck that on the stack, it fired off request. I don't have anything else on the stack that's blocking at that point, because at that point run is actually resolved, and we've got request up there doing its work. And once it's done, it's going to push this back onto the stack, right? So in fact, once that's done, what you'll see is that this unnamed function gets stuck in the event loop. Right, that unnamed function gets stuck in the event loop. Because the call stack is empty, it's going to get pushed into the call stack, and what you'll see is that will go into the call stack as a method call. You'll get an if check. You'll get an if check on the call stack. It'll resolve if false. It'll stick a console on there. Ooh. Right. I'm not doing it very well, but are you tracking it?
Yeah.
Yeah. So yeah, as soon as you hit here and you make that first request, effectively your call stack's clear, because you're waiting for that to finish. And what it does is when it's done, it sticks this back on the call stack. Right? So it's got its own little thread, it's got its own loop. It's going to queue that back up as a function on the call stack, and it'll start executing down that thing. It'll hit callback, which is still theoretically in memory because it knows that this thing was waiting for that piece. So effectively, this one actually would not have. Yeah, so that one will be cleared out because this function will still be waiting out. Does that make sense? Yeah.
Request parallel.
Parallel?
Yeah.
Oh, and the simple.
Or
yeah.
actually neither of them. You have that. What is that last dot all? You have a dot all like a promise style. That I get. What is that last dot all?
Oh, sorry. That's just sorry. That's this thing right here. Yeah. Catfax, the API has an all.
Oh.
Sorry, the object that it returns. If you want the entire array. Yeah. Yeah, that's probably not very clear there. Yeah, but that's just I parsed the response,
Okay.
and that's a property of that response.
Do you ever do you try to go all one way or all the other? So, you said you try to get the same function right away, but you can still do promises. Do you ever find yourself kind of mixing and matching for your purposes?
If I'm using an existing platform or whatever, I'm trying to match that platform that somebody else's code is doing. I'm not typically trying to introduce this into an existing code base. I'm certainly refactoring all of my code. I've got a lot of callback-based stuff that I'm switching over. But no, I don't want to mix and match. I'd like to kind of get into a pattern and then you kind of just roll with it on that project kind of thing. But if it is going to convert, yeah, I'll start writing new stuff with async await, and then I'll start migrating stuff over. The great thing about the promise-based stuff, though, is if you went that route, it still works, right? You don't have to change anything about those existing method calls. You can actually leave them alone and still consume them in your async await stuff, and just clean up your code that uses those things, right? That's the nice thing about at least using promises, is that it's directly usable this other way. Except for
You use async await in contexts where IE11 support is important.
what is that? No.
Okay.
No, I mostly fell into it with Node.js stuff, server-side stuff. IE11 is not going to have it, right?
No, it doesn't have it. There's like a Babel function.
And I think that's probably an answer though too. Is even rather than using a plugin, I was even talking to Brian about this too. At one point, was maybe changing up your build process on your JavaScript libraries and having a compile step that will cross compile or down compile. So I write in ES6 or ES whatever, and it all gets down compiled into ES5 or something like that. because you certainly can. Babel will certainly convert all of this into something that will work in IE11. I think Levi was saying that it's pretty hairy. Pretty
async await transpiles into some hairy code.
pretty hairy stuff. Yeah. In my mind, so no. In my mind, probably not. In fact, what I'm reading is that async await can be optimized a little bit more. So while I was talking about the call stack being identical, there is actually a little bit of statement out there that says async await can get optimized, but probably not in a cross compile, but probably in a sheer runtime. But if it's just a cross compile, I bet it's the same. It's got to be. In my mind, it's got to be the same.
Not for IE11.
Really?
It doesn't go straight into promises. It like creates a generator function which it transpiles. Generator functions aren't supported in IE11 either, so it transpiles that. Those get really hairy. It doesn't look pretty though.
Yeah.
But if you were gonna go with IE11, you would need, if you needed to support it, you would need to transpile the async await, but also a promise polyfill, because promises aren't in IE11 either. That's just a language construct. But that's a polyfill thing, not a transpile thing.
Yeah. What now? What was that browser called again?
You're the one using Windows, okay?
All right. Any more questions? I am going to move on to one more, even more semi-complex scenario, and that's the last one I've got. I'm certainly open for any questions. I get that it probably feels a little gobbledygooky. But let's just roll. All right, so this is a Mongo database execution, right? So in my server-side stuff, I use a Mongo database for stuff on the back end. It's a little bit contrived, but what this thing is doing is grabbing quit bits, right? It's saving it out to a file, and then it's looping over every quit and stuffing them into a Mongo database, right? Not terribly complex work. But there are several things that you have to juggle in order to make that happen. Okay. Let's talk about it from a high level really quick, and we'll walk through it. This is where you start to see, again, callbacks starting to chain and nest, right? So at the very top, I have to connect to the Mongo database, right? So I have to basically get an object that allows me to talk to the Mongo database, and I need that for other calls later in the chain. So I connect to the Mongo database. Obviously, if it errors, I exit. I get a list of quips. If it errors, I execute. Otherwise, I grab the body. I write the file, and again, I error. A little bit of a trick here. I have to close the database. This is what I was talking about earlier. That if you don't close that database, it's actually running in a separate call stack. And if you don't close the database, it will always hang. Your program will sit there waiting for that call stack to execute, and it won't close until you close the DB. So here I am closing the DB if I error, kind of thing. So anyway, I grab the Mongo database and make a connection to it. I get the list of quips. If that's all good, I write that out to a file. Right? And then you remember our tasks earlier, right? So this is, it's the easiest way I can think to do it with callbacks without this being really, really, really ugly, where you juggle the array and you kind of count through where in the array you are, and then once you get to the end of the array, you say, hey, I've processed at the end of the array. You could do the same thing with recursion kind of thing, basically recurse through the array, pass the array in of quips, track where you are in it, insert one, move forward, call back into the function, try insert one kind of thing. Anyway, it's easier just to do a for each, right, for each quip in the quip list, and I push a task, right? So they're not executing at this point. I'm just filling in this array with the things that I want to do. It's a little bit heavy in my opinion because you do end up with an array with 517 items in it that haven't executed yet. It's not a heavy call stack, but that is basically what this is doing, right? I'm looping through, I'm making a function on the fly that I'm sticking into the tasks, and then right here on the end, I'm executing them in series. Remember earlier I had this in parallel, right? We made two web calls. The async library also allows you to say, I want to execute these in series. This is being nice to your Mongo database. Theoretically, you could make those all in parallel, and you'd have 500 calls being marshaled into that database at the same time, and if it can handle it, whatever. I'm just doing it in series here, so that they do it one at a time, right? So we cheated, and this thing did the heavy lifting to make sure that these all executed one at a time. I don't think... It's going to take a few seconds. I think most of the time is actually getting, getting the quips. But you can see here that I've got this call in here, right? I say I'm starting it. I'm starting to put it in the database, and in here I'm done putting it in the database. Right? You can see starting, done, starting, done, starting, done. If we were hard on the database, right, we could say do them all in parallel. I think you'll see a lot of startings and a lot of dones. Does that make sense? Just not very kind. All right. Promise will feel familiar, right? It's the same concepts. I'm putting a global variable here, or at least a higher scope variable, so that I can get access to it. I'm connecting to the database. Then, when I'm done, I'm making a request out to get the quips, and I'm returning that. So my next then can handle the body, right? So in this statement, I'm writing that body to a file, and I'm returning the quips. Remember what I talked about? If you don't return a promise from the then, you can return just a variable, and it's inherently converted to a promise. Inside this, basically, we're getting the dot then and then getting the quips back out. So my next then gets the quips. I don't know if I can talk a whole lot about why this works. This is some hackery. This is a way to loop over all of some items in an array and to execute a promise against those items. I'm gonna have a hard time explaining why this works. If you're ever looking into it, look into map reduce. Look into reduce for promises, and you'll find this pattern. But basically, you end up being able to loop over them all, and at the very end, I can resolve that it's complete. I really struggle explaining why that works. The guys who figured that pattern out are smarter than I am. Anyway, it's a trick. There are other patterns, there are other libraries that will allow you to do it. You could throw these all into a task, and you could do all the parallel stuff against them as well. This is a more succinct way to do it. And it was the same concept, right? And then at the very end, finally, I close the database, and I resolve. Fingers crossed, we get it done. Ben, I was telling you, if we don't close the database, right, if I leave that open, I should just hang, right? It says DB closed, but it didn't really. And it's just sitting there waiting, kind of thing.
One pattern that I use a lot instead of the reduce pattern is you just use a map. You collect the asynchronous tasks into your promise.
Yeah, okay, you could do a promise all.
It's a little bit easier to read.
It would be easier to read too, and that'd be the same difference. So yeah, that'd be a map that would create like this, a list, and then you would do a promise all. Yeah, that would work really well too. And then async await. This is where again it gets just kind of nice and clean, right? I connect to the database. I get the quips. I write the file. Not that this is important, I just parse it. This is the trick. This is a little bit of a trick. A for each loop is a tight loop, right? We did that earlier where we made that for each loop, and we saw that the call stack never cleared and never allowed anything to kind of come into the stack. I've written this method about 1,000 times, async for each. It's basically just a modification of a loop that allows you to pass in a callback, a promise callback. So effectively you get a for each that allows you to await for them all to be done, kind of thing, right? So it's an async function that resolves when each of the items are completed. So it gives you this handy syntax, right? Wait for an async for each every quip, write a quick little async function to execute, wait for the database to do an update, and then it's just done. But, right, just 1,000 times more readable. That's all I've got. Oh, I got one more thing. One more thing. So you remember me saying that you can't put your own code into that that web API call stack, really? You can't write your own threaded code? Was challenging myself thinking about that. I was going to say, I'm going to say that you can't ever do that, right? And I was like, I'm going to make sure everybody understands you can't ever really do that. Can you really never do that? And you can. So there's a little trick. You guys know what web workers are? So I've got this page. I've got a web worker concept, right? So 1JS. This was that same call that we had before, right? I'm going to kick it off, and then I've got this long-running task that I was executing before, right? So I've got these long-running tasks, and I had that loop. See if I can find that real quick. Right? I did this thing, and I've got all this stuff in a loop that I want to do, right? And it kept this call from coming back until all of this was done, right? Theoretically, I actually, with a web worker, I can put that code into a separate thread. So over here, I've got that same code. In fact, take that out and take a couple of these out. It's that same code without the loop, right? All this code does is it fires off another thread, and it says, hey, this JS file has this other logic in it that I want to run. If we look at that JS file, I could have just put this in here, but here's my loop, right? Here's my loop. Do all that work. When it's done, say I'm done. But this is a tight loop, right? So I am kicking off a web worker, and then when it's done, I'm just going to respond that the web worker is completed. But that fires off immediately, right? So that spins off another thread, and I'm going to say, hey, I want to run my long-running tasks. I've got several of them looped in here just so that you can see the way the responses come out in the browser. Kicking it off, I fired off the web worker, and you can see I'm starting to get some of my responses while the web worker is still working. Right? Remember how in the earlier example, I wasn't getting any of those callbacks until after the entire thing was completed, right? That for loop was running, and I only got those back after that for loop was completed. Well, theoretically, this web worker is doing that loop over there, right? And I'm getting these in. Anybody notice anything kind of interesting, though, about the timing? Watch the timing of it. Right? Sometimes these come back right away before the web worker even kicked off. This one comes back. This was supposed to be 2 seconds later. That was well over 2 seconds, in my opinion, right? If we think about it. This 400 millisecond piece took a while to get to, right? That's a long time, over 400 milliseconds. So the timing is not actually precise, right? So I am getting the events to eventually get into the stack, but the timing is really not there, right? I said I wanted to do this in 400 milliseconds, and it did its best, but that web worker over there has got this tight loop too, and it's eventually throwing these things in the same stack. So while it's proof that it can work, if you have a tight loop in a web worker, it still is going to kind of conflict with getting your things in there. Solve that problem too. And that's what I was talking to you, Jason, about. Theoretically, right, I can run the same loop, but I can just say, hey, give this thing a break after every item. So instead of running the loop so tight that I'm just console logging and going into the next, if I fire off another threaded call, effectively I've given up control for a less than a millisecond, right? I've given up control for less than a millisecond. I should be able to see these firing off at about the right time. And there's the web worker kind of kicking off, still doing its work. Does that make sense? And 2.5, yep. The timing is there. These are a little delayed, but theoretically it's correct.
What workers support all browsers?
I don't know. Oh, quite a few. IE 11. So that's really all. IE 10, right? Yeah. What's that even? IE 6 probably. Okay, I'm really done.